What is guys today we're going to be talking about erosion corrosion. Erosion is like the natural process where Earth's materials like soil, uh, rocks, sediments gets worn away and it gets transported by ice, wind, water. Okay, so erosion corrosion is when you got water flowing in the pipe and it's it just keeps flowing and it's flowing like fast, right? And it's wearing away that metal oxide film, and that's really bad because now that film uh, has the metal underneath lying unprotected and now it's vulnerable to chemical attacks. Okay, so that's good to keep in mind. Another thing to know is laminar versus turbulent. So turbulent. So laminar is like when you pop a balloon with water in it and it comes, the stream coming out looks like it's not even moving. That's laminar flow when the water's moving like perfect layers right on top of each other that where the stream doesn't even look like it's moving. It's that perfect. Turbulent is like violent. It's going like the water has no direction and it's really fast and violent flow. Okay, so things to keep in mind before we start this lesson. So one of the first types of corrosion is flow-assisted corrosion. Okay, flow-assisted corrosion is when the the high-speed water is shearing the metal. Shearing is like scissors, right? It goes like scissors goes like that. It shears. The water is going really fast, and then the pipe is not moving. But I guess the normal force of the pipe is pushing back, but not enough because it's the flow-assisted corrosion is when damages it. Uh, it damages it enough that it can't regrow back in time, right? Like it kind of it damages so it damages more than it heals, right? That's what flow assisted corrosion is, and that is really bad because then the pipes just keep getting thinner, thinner, and thinner until it could like leak or explode. So next thing is impingement. Impingement, think of a sandblaster. It's like think of when the pipe is going like straight and then right away 90 degrees. Okay, think of the 90 degrees turns. That's really bad too because when think of it like sandblast, right? It's like it fires tiny hard particles at a surface. The water, the water is moving so fast at turbulent flow, it's almost like sand, where it's just think of a high pressure hose at a wall at an angle. The fluid slams into the metal surface with really immense force, and it creates a directional pit or grooves in that metal. Kind of look like comet tails. You know how a comet moves like that? It leaves that on the metal, pointing in the direction of the flow. So that's the second thing, impingement. The third thing is cavitation. Cavitation is the most violent form of erosion corrosion. That's when pressure change, okay? So when the pressure drops, the liquid kind of actually boils for just a split second and it creates a tiny vapor bubble. But when the pressure rises up again, the bubbles implode. And the damage, so what the damage is when each implosion fires a little microjet of liquid at the metal so fast that it's kind of like a microscopic jackhammer. Okay, so over time, this literally punctures thousands of holes in the metal, making it literally look like a sponge. So that's really dangerous. So first, so what are ways we can like prevent erosion corrosion, or like materials we can prevent? We can use titanium. Titanium, think of it like a healer. Okay, healer. Um, it has really super healing skin. So the second example I was talking about, the no, sorry, the first one, flow assisted corrosion, where it's getting damaged faster than it can heal. Titanium has super healing skin, so it works because when the moment the fluid scrapes the surface, titanium reacts with oxygen instantly to regrow its protective skin. So this is best for saltwater or really high speed flow and is bulletproof for erosion corrosion. The second thing is the shield is cobalt, sorry, I can't, cobalt alloy. Cobalt alloy. That's like industrial armor. It doesn't just sit there, it like fights back. So when this metal is incredibly hard, okay? So when these tiny cavitation bubbles implode, the metal doesn't dent or pit. It actually gets tougher the more it gets hit, right? So that's called work hardening. So this is the best for pump parts and valves that take constant beatings, okay? And last but not least, duplex stainless steel. That is the muscle, okay? Think of this as a high strength hybrid. It's a mix of two different types of steel structures, and how it works is it's a really much stronger and thick skin rather than your regular stainless steel used in your kitchen sink. And your kitchen sink stainless steel is pretty strong too, at least mine is. So it's probably like double the strength or whatever, and it's really thick so that it can take that water damage. So that's it for erosion corrosion. Thank you for watching my video. I'll see you guys in the next one.